Alright, guys. It's late, I know. I did not plan on doing this, waiting so late, but today I'm gonna try to fix the. I'm trying to add egg side platform collisions because right now, if it's just AABB collision and we check for bottom collisions so that we can bounce the egg off a platform, but if the egg is hitting the side of a platform, it treats it as if it's a bottom collision, which shouldn't be the case. It should just bounce, revert its DX, and then keep falling. So hopefully we can figure that out today. It's going to be a little tricky to test because we have to kind of time it so that when we kill someone that their egg would go fly into a platform. So it's a little hard to test. But I'm curious if we have would our egg platform collision be here somewhere in our play state? We check egg. No. Where do we check our egg? Here. Here we go. So yeah, look, we've got a ground collide function that takes in a platform. And we're cycling through all the platforms and seeing if the egg ground collides. Let's take a look at our vulture.egg ground collides function. Ground collides, ground collides, ground collides. Really? Where's our ground collides function? We have a ground collide platform for our vulture.egg. So would that be a egg function? Okay, so it looks like we've got. Like, guys, I'm just like a bit hot. I'm gonna put on a lighter shirt. Okay. So we've got a ground collide function that takes in a collidable, which in this instance we're cycling through all the platforms to check for we need to check for side collision. So we need a function that detects side collision, and then we need to incorporate logic that uses or that changes something upon side collision. So if we take a look at our ground collide function, we're seeing if the left side of our egg is smaller than the right side of our collidable minus a buffer. And we're seeing if the right side of our egg is greater than the left side plus the buffer. We're also seeing if our y is the top of our egg is smaller than the bottom of the collidable height, so bottom of the platform, and we're seeing if the bottom of the egg is greater than the topmost part of the collidable. So this isn't quite what we want. This is this works for sure. So I feel like there's two ways of going about this. We can either keep this ground collide as is and just add our side collide with a platform function. And if we do that, we would need to check for a side collision first. Because the thing is, this is like a true AABB collision minus the buffers, but if our egg is colliding with that platform, like let's say this is our egg and this is our platform, our egg's beneath the platform, if that couldn't really happen, but if it's going to the side and it flies in like this, you know, it would say, oh, ground collide is true, move egg up to here. So that's why we would need to check for a side collision first. Be like, hey, is this a side collision or is this a bottom collision? And with a side collision, we can get more in depth. We say, hey, like if the left side of the egg is hitting the rightmost side of our platform, then we need to swap its dx. We need to move its y position, swap its dx, and continue applying gravity. At which point the ground collision wouldn't be true. So I guess the question is, can we do a function that detects side collision better than it detects bottom collision? Because the other problem is if we try to detect our side collision first, when the egg comes down into a platform, we're checking for side collision, which this would ring true as a side collision. Yeah, I feel like we do need to modify our ground collide function to just, instead of doing the whole AABB, we're checking the bottom half of the egg, and if the bottom half of the egg is colliding with the top half of the platform, then we know that's a top collision, or a ground collision for the egg. But if the left side of the egg is colliding with the right side of the platform, that would need to be a side collision, and we check side collision first because I don't know why exactly, it's just I feel like we need to, because the ground collide will become true when a side collision should be true, so it's like we kind of give precedence to the side collision. It gets a little more tricky than that though, because if the eggs, because we have to come up with two different side collide functions, right? When a left egg collide with platform function and a right egg collide with platform function, because we need to do two different things depending on the side of the collision. But it's a little more complicated than that, because if the egg's kind of falling at an angle like this, and the end of our platform's right here, platforms are like right here, eggs coming this way, and it hits a left collide with the egg, we would say swap our dx, because a left collision would technically mean that the egg's coming from the right side moving left. Then we would swap our dx. But if the egg's flying like this, it barely clips the left side there. If we check for side collision first, then it would say, oh, left collision, true, swap our dx, which would move us this way, which would determine another side collision, which would flip its dx, which would flip its dx, which would flip its dx. So maybe we do check ground collision first. We just need to make sure we're checking the bottom of the egg. Okay, now our eggs, height is at 8, width is 8. So we don't want to do this true AABB collision. We want to do a modified bottom egg collision with top half of our collidable platform. So part of me wants to just nix all this and try it from scratch. So I'd like to draw this out. It helps me walk through it a bit. You know, here's our self is an 8x8. So we're trying to see okay. Jimmy's on the corner of the vivarium, like spread out on the corners. It's really freaking cute. It's like doing the splits. His bottom legs are like this, and top legs are like this on the corners. Okay, then we need a platform. Top half. So yeah, by doing a little more of a controlled AABB detection, we're gonna be checking for the ground collisions a little bit cleaner. Okay, and then we'll come up with the functions for the side collision, and then we can worry about those intricacies of swapping the DX and or not doing it depending on which direction the egg's flying, because that would actually matter. It would be rare, but it would matter. So okay. X is smaller than bottom, top side smaller than bottom side bigger. Okay, so let's do this. We're trying to do a simple modified AABB collision here. So we're going to say if the top of our bounding box, which in this case would be our self. Oh, yeah, we gotta do, I normally do X's first and then Y, just because it helps me think about it, I guess. So we're trying to see if the left side of our box is greater than the collidables X. Hold on a sec. So we're trying to see if our left side of our left side needs to be bigger than the left side but smaller than, no, right side. See, my old code is confusing me now, because now I'm like comparing it, but we see if the left side is smaller than the rightmost side. Yeah. The rightmost side would need to be bigger than the leftmost side. Okay. So we're trying to see if the left side is smaller than the rightmost side. We had this buffer for whatever reason with a +1, and then we need to see if our right side, so our self.x plus our self.width, our right side is smaller than, nope, right side is greater than the leftmost side. So collidables x plus its buffer, but not as much of a buffer. Okay, and then here's where we need to modify our old code, where we say we're checking the y's, but instead of checking the y of the entire bounding box, we're shrinking the bounding box to be the bottom half of our egg and the top half of our platform, so that we're only really checking for that ground collision. Yep. And it's a little arbitrary. I just did half. We can probably get away with doing a little bit smaller than that to kind of smooth out edge cases, side collisions. So yeah, we're gonna say we're gonna be checking the topmost side of our egg. No, we're not. Let me just get the logic sound and then I'll with the right value. So we're checking to see if the top of our egg is smaller than the top of our bounding box is smaller than the bottom of our collidables bounding box, which for now would be plus the collidables height. But we also need to see if the right side, if the bottom side, the bottom side of our trying to see if the bottom side of our bounding box of our egg is greater than the top side of our collidable platform. And if that's true, return true. Else, return false. Okay. Now we need to switch this. We're not trying to see if the top of our egg, we're trying to see if the top of our egg plus, so +4 would give us exactly half, but if we do +5, it'll give us a little smaller than half. I'm just trying to minimize the chance that we detect a ground collision if the egg's coming. So if we shrink the bounding box of our egg, shrink the bounding box of our platform to be less than half, then it has to basically ground collide. And you know what? We can take out the buffer for our side detection, so that if it's a true side collision, no matter what, it'll just bounce its dx. Yeah. There's still that issue I can imagine happening there, but so we're trying to see if the top of our egg plus 5, which is a little more than half of its total height. Trying to see the top of that bounding box is smaller than, not the bottom of this collidable height, but half of this collidable height. Okay. And then we're trying to see if the, not the bottom, no, yeah, it would be the bottom. So if that y plus all of its height is smaller than, no, is greater than the topmost part of our collidable. Okay. Yeah. So here's what we changed. On the Y detection, we give it a little more. So it's only detecting the bottom half of the egg, a little less than bottom half of the egg. And we're also checking the bottom half against the top half of our collidable. Other than that, no code has changed. So part of me wants to just see, oopsie, if that breaks anything. It can be hard to test. Actually, that's just the ground collision, so yeah, ground collision is pretty easy to test. Okay. So it's still working. Nice. Cool. So we just made our ground collision function a little more robust because we're going to be adding 2 more functions. Before midnight hits, I'm gonna commit added more robust ground collision detection for egg v platform, just because I want to get a green mark for today on GitHub in case I don't commit before midnight. We need 2 more though. 2 more functions. We need a egg left collides with platform function. And we need a egg right collides with platform function. And we need to check similarly, not the true AABB, but the left side, the right side. So for left collide, it's if it's and with the X something like this. I don't know if you can see that. But that'll be our side collision. So trying to think of this. Okay. Yeah, we need to see. So we're going to say if the left side of our egg is smaller than the right side of our collidable platform, and our right side of our bounding box, which is going to be our this plus 3. I want to say it's 3 because we did a y plus 5. It doesn't sound like it makes sense, but the y plus 5 would be checking if the bottom 3 pixels of our egg was colliding. So that's the reasoning here, except instead of the bounding box being the bottom 3 pixels, we're checking the left 3 pixels. Now, I'm actually just going to change it to 4 for simplicity's sake, and if we need to change that, if it isn't working quite, we can shrink that threshold down a bit. So just because the 5 and 3 really bug me, we'll keep it at 4, which the 4 should actually probably be width divided by 2, you know, and height divided by 2, just to be a little more verbose. So our width divided by 2, which is 4, and this becomes height divided by 2, which is 4. And then, so we're checking if the left side of our egg is smaller than the right side of our collidable, and the rightmost side of our bounding box of our egg is greater than, here's where it's a little tricky because it's collidable's x plus its width, but shifted by, we want to see if it's greater than 4 pixels in from the side, you know, which I guess we might want to do self.width divided by 2 again, just so we don't have a floating 4 in there, you know. And we can modify this with an offset of however many pixels we want if we need to. So we're trying to see if the left side of our egg is smaller than the right side of our platform, and the right side of our bounding box of our egg is greater than to the right of, not the right side of the collidable, but greater than the right side of the collidable shifted in by half an egg's width, which is 4 pixels. And then if those two are true, we need to check for the y. So we would say, now we need to see if the top of our egg is smaller than the bottom of our collidable platform. Top of our egg smaller than bottom of our collidable platform. Dot height. And we need to see if the bottom of our egg, surface dot height, bottom of our egg would need to be greater than topmost part of our collidable. And if that's all true, return true. Otherwise, return false. think that's right. So that's for a left collision. We need to check right collision now. It really helps me to draw out these little diagrams because it's just hard to visualize it in my head. Okay, so we're trying to see if the left side of our bounding box, which would be our self.x plus half of our self.width, that would be the left side of our bounding box, which for a right collision is halfway into our object there. So we're trying to see if the left side is smaller than the right side of our, it would be collidable x plus that same self.width divided by 2, which would be 4. I just didn't want to put a 4 in there. So left side of our bounding box of our egg, trying to see if our left side is greater than, no, left side is smaller than the right side of our platform's collidable bounding box, and our right side, which would be self.x plus its entire width, and right side would be bigger than just the left side of the platform. Then check the y's. Our top of bounding box on our egg would need to be smaller than the bottom of our collidable's bottom edge. And our bottom of our collidable would need to be bigger than the topmost part. Of our collidable. All those are true. Return true. Otherwise, return false. Okay. You know, part of me wants to do that old trick where we put an egg instantiation on our mouse position so that we can move it and make sure we're detecting these collisions correctly. Part of me really thinks we should do that. It's just a lot of work. I mean, it's not that much work. I think it's probably a good idea to do because it's just too hard to test the egg's collision logic. You know, we'd have to not only kill a vulture, or we have to kill a vulture and have its egg fly in at a certain angle to hit a platform, and then we have to see if it does it right. It would be easier to just instantiate an egg on our mouse position and then test collision for platforms. Then we can worry about the logic once we get the collision working right. I think that's the way to do it. I don't exactly remember how we did that. We did it with the vulture collision, right? Yeah. Wonder if in our vulture collision we have any remnants of that. Oh yeah, we do. So look, we have this mouse X and Y. Okay. Wonder if we have our mouse. Nope. Okay, shit. It was, what was it? Get position? Mouse get position or something like that? It was something like that. Love 2D mouse get position. Yeah. But we, oh here. Love.mouse.getX. Love.mouse get Y. So if we have a variable called mouse X, mouse Y, we store in the result of that function that love has nicely made us. Then we update our eggs instantiation to be the mouse.get mouse X and Y, and then we render it at mouse X and Y. Then we will be able to have a mouse on our pointer, and then we can print out debugging for the platforms and test if our collision's working, which I think is the best way to go about this. Love.mouse.getX, love.mouse.getY. So we've got an egg class that we need to instantiate an egg. So let us, in our play state here, I'm gonna say self.eggTest gets an egg instantiation, okay? Now the egg instantiation needs an X, a Y as a starting point. Oh, see, so it's a little different because eggs don't have a we just need to overwrite all of our update function for our egg with mouse location stuff. But shit, man. Okay. So last X dy dx. I guess it would just get 0 dx. Let's just say we start the egg at a 0, 0 with a 0 dx. Okay. Now the last thing we want to do in our playstate update is overwrite we want to overwrite our self.eggTest object to be well, we want its X to be overwritten, we want its Y to be overwritten, and we want it to be overwritten with mouse Y and the mouse X, which we need to run love.mouse.getX. Is that right? love dot. Yeah, we need to store in a variable the result of get y function. So we need to say love dot, yeah, love dot mouse dot get y. We need to move that into our mouse x, mouse y, and we need to give ourselves these variables here as well. I'm just gonna actually move it into a self item just because I'm not trying to deal with any bullcrap with variables, global variables and whatnot. So I'm gonna say self dot stuff x, self dot stuff y. We're gonna move those values into our egg instantiation, and then we need to also render said egg of our egg test at its correct position. So we will say that we need to render self.eggTest render, and it'll render it at its x and y position. Actually, its last x and last y position. But we're overriding this. Overriding that manually, the dot x and dot y with our get y function and get x function. You guys think that'll work? I've got like zero faith. I don't know. I don't know what went wrong. It says y wasn't right. Oh, look at that. We've got an egg. Oh, that's right. I forgot. How did we fix this? I guess we don't really need to fix it. So the problem here is, yeah, we're giving our egg instantiation our x and y of our mouse, but since we're rendering at the virtual resolution, our egg is like this. I think that's okay. We don't need it to be perfect 1-to-1 ratio with our mouse. But we would like if the egg is white. So we will do a love.graphics.setColor to be perfect white, full opaqueness, and then why don't we print out why don't we print out whether or not egg ground collides with platform. Right, so we're going to take that string, we're going to concatenate it with another toString of our self.egg test ground collide with a collidable that is platform 3. And so that should print out either true or false whether or not the egg collides with platform 3 on the ground. And platform 3 is, you know what, platform 2. Let's do platform 2. It's that big one in the middle. This one right here. Let's do platform 2. We're just trying to see if the ground colliding works. Nice. So it's looking like we didn't quite do this exactly right. Because we want to do, remember, we want to check if, like, it should be false right here. It should be false here. We just want to see if the top half of that platform and the bottom half of that egg is true. So the Y's aren't quite right on that. So let's take a look at our egg ground collide. See, we're checking if the top of our egg plus half of its height is smaller than and the bottom. Oh, here, this is where we fucked up. The bottom of our egg would need to be, no, that's right. Bottom of our egg is bigger than the top, but the top of our egg, we're only checking the Y plus half of its height. So why don't we just do a plus 4 here explicitly, or plus 5 here. So the top of our egg is actually down 5 pixels from the top, checking to see if that is smaller than the bottom half of this collidable, which we can also put, just trying to make that window smaller so we can make sure we're getting the right functionality. True. See, that's better, but it should be false right here, not false until down here. But it is better. So we want it, you know, we want to see if we do a +6 and then a collidable Y plus, I don't know, +2. Just trying to shorten that window. True. Should be false when we're halfway into it. Nice. Yeah. So yeah, that's, so like the thing is here, see, look at that. So yeah, that doesn't trigger, That's quite a bit of buffer. Quite a bit of buffer on the X. You don't want that much buffer. If we take that buffer out, this is why, yeah, this was definitely the way to go about it. Not losing my mind trying to explode a vulture right in the right spot. Yeah, we want a little bit of a buffer, because see how that shouldn't be a bottom collision. So we do want a little bit of a buffer. 2 pixels. And the right side of our egg is smaller than or greater than this plus 2 pixels. What is our buffer, by the way? 6. Okay, yeah. Play state, no. Just. Okay. Cool. Yeah, see, that should be probably not a bottom collision, right? That's like getting really pixel peepy, but it kind of matters. We'll give it 1 more pixel buffer. Which we could do buffer divided by 2. 3. Cool. I think I'm okay with that. Cool. Yeah. That's looking right to me. Now we need side collision. Check. So we're gonna do test egg left collide. With that same platform, except we're gonna say nice. So if the egg's coming in like this, triggers left collide first, swap its DX. If the egg's coming in like this, triggers bottom collision first. Ooh, does kind of both. So we can make, yeah, we need to make this buffer zone smaller for left collide. Yeah, see, that shouldn't be true. It should be true, like that should be false still, but maybe not. Because that would be, it'd be the frame before a collision, but that would mean it would collide on the very next frame. So maybe that's okay. But we should have it, it should be false, probably about there, instead of there. Because if we come in from the top like this, we don't want both of these to be true. We just want bottom to be true. And if it's in the corner like that, then it defaults to whatever logic operation we determine is appropriate. So instead of having our 3 here, I'm going to put buffer divided by 2. Same with here. That shouldn't change any of that. But then, man, oh shit guys, I'm sorry, I'm tired. We want, you know, we want it to be true when x is smaller than this -1, like, and then the right half is greater than, the 4 pixels, so we can say our right. Trying to see if the left side of our egg is smaller than the rightmost of the collidable minus that 1, so it doesn't detect right next to it, but it has to be inside of it. And then the right side of our egg needs to be bounding box, right side of our egg bounding box, left side needs to be bigger than the left side. Right side bounding box. So we can either shrink our bounding box or shrink our platform bounding box, or do both. I guess we can say that the left side is the left side, but the right side is a little bit smaller than this. Let's see that. So, yep. Now, remember we were just getting true when it was like this in the frame there, but now shit. Okay, I can't really do that. But left, true. Cool. Yeah, maybe a little less. Yeah. Maybe just a little less. Let's see that the right side of our bounding box is smaller than. Let me see if I put a -3 in there. Okay. Yeah, it looks like we've got about 3 pixels of that left collision detection, which I think is okay. So look, right here we would get both true, which it's kind of, you know, at the angle there. So at that point, it's anyone's kind of game, whether it's a bottom collision or a side collision. So I think that's the perfect kind of sweet spot. Bottom, left. Cool. So if the egg's flying in, look at this. If it's flying in, it would bounce here. Shit. So that registers true as a left collision, which makes perfect sense because the collidable object is actually a rectangle, but we're only rendering a curved thing. So what do we do? Do we allow that? Is that okay? This is so cool. I love this. And all the music, you know, you're hearing is programmed by Sonic Pi. Well, by me in Sonic Pi. I was getting some copyright strikes because some other person had a song that probably used Sonic Pi, but it was on Spotify or whatever, so some of the ambient stuff got tracked on, got a copyright snagged, but I disputed him. Let's give it like another 2 pixels of detection. Another 1 pixel or 2 pixels on the X. If our X is smaller than -2. I don't think I want to do more than that. It's tricky to find that balance, because now this is still a true, but this is not. I think I'm okay with that. Yeah, I think I'm okay with that. That looks like a more acceptable tolerance. So now we just have to hope that however fast our DX is, doesn't actually go from here on 1 frame to the very next frame being more than 3 pixels over, because then it would totally miss the left collision. Yeah, we need to have it, I think 3 pixels is the right tolerance for that, so we're checking the left side 2 pixels in. I check this, not -3 over, but -2 over. It's just hard to find that perfect balance. We just want to make sure we have 3 pixels, probably, yeah, 3 pixels of that left collision, because we don't want the DX to be so fast that on 1 frame it's a not left collision, and then the very next frame the DX is so high that it actually goes past all 3 of these pixels, or two before we fixed it, and got to here in the next frame, because then it wouldn't detect a left collision, even though it would be inside this thing. So that's the downfall of doing the more controlled AABB collision, because it can miss. Look right here, no collisions being detected, whereas before we at least rendered a ground collision. So like maybe we have a catch-all. Do that. I was gonna say have a catch-all of like, you know, check for ground collision first, left collision first, second, right collision third, and then do an overall collision fourth to prevent anything being caught. But if anything's caught in like that, we have to give it logic. Or where do we put it? Do we put it at the top? No, it would depend on which area it's flying through, where it came from, and that's a lot of details. I don't think our DX of our egg's gonna be that fast to go more than 3 pixels in a frame. But maybe that's a calculation we need to do. What is the DX? What is the DX of our vultures in tier 1? 0.5. Okay, so yeah, 0.5. That means every frame they're going 0.5 of a, you know, pixel. So unless they were going faster than 6 times that speed, they wouldn't get that issue. So I think we might be okay. Let's do the last test of the last right collide. Gosh, I'm about to fall asleep, you guys. Right collide. And in our egg function, we need to say just how this was. Uh-oh. Oh my gosh, hard for my brain to realize. It's seeing if the left side of our egg is smaller than the rightmost side of our collidable platform is a 2 buffer. So we're seeing, I think we need this to be -2 to be safe. But then smaller than left side of our it's swapped, so it's hard for me to picture this, to make it equal to our left collide. Left side of our ostrich, no, the left side of our bounding box of our egg is smaller than what? The left side of our egg is okay, the right side of that, which is +4, but we need to do we want it 3 pixels, I think. And then the right side of our egg greater than this plus the 2 pixels buffer that we've got here. And then that might be it. Not quite. That should be true. So the left side bounding box smaller than the right side of our egg, greater than this. Shoot. Yeah, I'm glad we did the mouse thing, because this would have just driven me crazy. Nice. Right collide true for 1, 2, 3, 4, 5, 6, 7. We need to be less sensitive by 3 frames or whatever. So we need to see if the leftmost side gets shifted over. 1, 2, 3. Next 3 false. Nope. No. Jesus, what does that do then? Left side is smaller. Right side and left side. Left side is bigger than collidable X plus. No. If the left side of our rightmost bounding box is smaller than this. One, 2, 3, 5. Okay. We want it to be 3 pixels just like the right side, so it's like oh fuck. 1, 2, 3, 4. Okay. 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 I think I'm happy with that. And an egg, you can't really have a top collision on the platform because the egg's not going to be bouncing high enough to get there. Okay, well, I'm happy with the collision detection. I don't think I'm awake enough to implement all of the functionality just yet, but we've got a huge good effort. We're gonna add everything to the staging area and commit with a message saying added egg side collision functionality. We're gonna push it to our origin main, and we're gonna call it a day. We added the collision detection, but we need to add egg side collide logic. Cool. Yeah. All right, calling it a day, I guess. I'll see you guys tomorrow for another session. Catch you.